Hey, algebra. So let's do a little bit of remembering. Last week, one of the things we looked at was stacked some cups and measured the height of that stack of cups. So here are some of the expressions that I use to explain the stacks of cups. Um, H in parentheses 588 equals something. And another one that I used was H with parentheses X equals 22.9 centimeters. So both of these two expressions have the parts are the same, right? There's a green part that highlighted in green. There's a part inside the parentheses highlighted in blue, and there's a part after the equal sign highlighted in pink. What do those three parts mean? Go ahead and write down on a piece of paper, scratch paper, or whatever. Write it on your hand if you want. What do those three parts mean? Hit pause. I'll be waiting until you're done. Awesome. Okay, so hopefully what we came up with was the same for everybody. The H stood for the height of the stack of cups. It's just a label. I had originally written out height of the stack, and it was too long, and I abbreviated to just height and then just to the letter H. It's an abbreviation referring to this function. Number two, inside the parentheses, this number was the number of cups I put into the stack, whether it was a number that I knew, like how tall is 588 cups going to be, or whether it was an unknown number. How many cups would it take? Um, okay, the number inside the parentheses was the input. It's the number of cups. And then the pink part after the equal sign, that is the output. It's in this case, it's the actual height of the stack, which is what the label was talking about. Whatever that label is, the name of it, that's this number. So the first question, the height of 588 cups is, no, I had to measure it. And in the second expression, the height of some number of cups would be 22.9 centimeters. I don't know the number of cups, but I know the output, 22.9 centimeters. Okay, so I captured those same ideas here into this more concise format. Function notation goes like this. There's that label at the beginning, whether it's F for function or H for height or D for dollars. I mean, it could be whatever we need it to be. Inside the parentheses will always be the input value, and after the equal sign is always going to be the output value. Okay, so a lot of times we use X to represent input. Sometimes the letter changes. It's not an X, maybe it's a T or a, whatever. And a lot of times we use Y to represent the output. And especially if we're thinking about graphing, it's going to be a Y-axis. Um, sometimes in story problems we use different letters. That's fine. It still refers to the output. All right, so today we have two learning targets using function notation. The first is you'll be able to put a number in to X as the input and evaluate that. And the second one, you'll be able to solve for an unknown number X. If I give you the output, you'll be able to work backwards to find what input that came from. And so I'm going to use this example. I do garden during the summer, and one of the things I grow is pole beans. And so pole beans, you plant them, down underneath the dirt, and then once they start growing, for the first like week or so, they pretty much grow at a set rate, and then later on that changes, and so it's not like the same rate forever. But um, so let's just say that this function represents the height of my bean plant after some number of days. We'll call the days x, and so each day that baby bean plant grows 3 centimeters. So 3 centimeters times the number of days. But I had to plant it underneath the dirt, so it's like 8 centimeters deep. So -8 will give me the total height of the bean plant after some number of days. Okay, so find f of 1 means how high is the bean plant going to be at 1 day. So I'd have to put 1 inside the parentheses. So here's my expression. F of 1 equals 3 times 1 minus 8. So the f over here, that's just a label. It's telling me I'm using the function that I named f. Inside the parentheses is my input. I'm putting 1 into this expression. I do not need to do any work over here. This part that I'm highlighting yellow on the left side of the equal sign, nothing happens there. I'm just going to leave it there. That's labeling the problem. It's going to label my answer also. All of the work that I need to do is going to happen over here in the part I just highlighted green on the right-hand side. And so I'm going to follow the order of operations. I need to do 3 multiplied by 1 and then subtract 8. If I remember GEMDAS, I got to multiply before subtracting. So I'm going to multiply 3 times 1, that's 3. And then I'll have to subtract 8. And 3 minus 8 is going to be -5. So after 1 day, um, the height of the plant is -5 centimeters. It still has not come up out of the dirt, right? So okay, the output is -5. If I want to keep track of that whole problem, I can label it f of 1 equals -5. F just tells me the name of the function. 1 is the input. -5 is the output. So this is telling me a whole lot of information in a very dense mathematical form. Let's do a couple more examples here. What about if I put 0 in as the input, find f of 0 is the same expression to start with, the same function. Let me get some space so that we're not confused by other stuff happening here. Okay, so I'm going to put 0 into the function. I like to just write it with parentheses and leave that blank space there inside the parentheses, and then I can fill that in. Um, so that it's clear to me visually, like this is where the x goes and it needs to be multiplied. So if I've got the 3 times those parentheses, I remember it's multiplication. Otherwise, it's like a 3 next to a 0, and you're like, does that mean 30? So anyway, I got to multiply 3 times 0. That is 0, and then subtract the 8. 0 minus 8 is going to be -8. So if I was going to write this whole thing, I would say f of 0 equals -8. But that -8 is the output. Then the assignment, that's what I'm going to need to put into my answer blank is just the output of -8. Okay. Last example here with this expression. What if I need to do f of -2? Okay, well, so the function value at an input of -2 is going to be 3 multiplied by that input, and then subtract 8. -2 is going to go in here, and my color didn't change. That's all right. So when I multiply first and then subtract, so 3 times -2 is -6, and -6 minus 8 is -14. If I was going to write this whole expression, f of -2 is -14. Does this really make sense in terms of a plant growing? No, not really. This would be like -2 days. I don't know how negative time works. I guess it's 2 days before I planted it, but that doesn't make any sense, right? Before I planted it, it did not have a height because I hadn't planted it yet. So the analogy breaks down, and analogies do that. But the concept for function notation